The fourth experiment in our syllabus is measurement of resistance using DC bridges. The objective of this experiment is to understand the principle and working of DC bridges such as Wheatstone Bridge and Kelvin Bridge, which is used for resistance measurement. To accurately measure the unknown resistance values such as low, medium and high, we can use the DC bridge circuits. To familiarize the distinction between the measurement of standard resistance and the very low resistance. For very low resistance, we will be using the Kelvin bridge, and for the standard value of resistance, we will be using this Wheatstone bridge. On doing this experiments, the students can gain hands-on experience in setting up and operating the DC bridge circuits, and to develop the proficiency in using instruments such as galvanometers, resistors and DC power supplies in the circuit. On completing this experiment, students can able to understand and they can explore the on completing this experiment, students can able to explore the practical applications of DC bridge circuits in fields such as instrumentation, industrial automation and electrical engineering.
Today we are going to see about this Kelvin double bridge. So there is in the measurement of resistance using DC bridges, there are two bridges. One is Wheatstone bridge, which is used for measuring the medium value, and Kelvin bridge is used to measure the low value. That is low value means below 100 ohms. The unknown low value resistance is connected in this RX. So here is the Kelvin bridge trainer kit. Okay, now we are using this patch cards. We are giving connection to the dotted lines. So here there is a dotted line L2, and here there is another dotted line, and there is an L1 connection to be given, and supply for this Kelvin bridge is given from plus 5 volt. So here A to A and B to B. So we had to give this supply source from A to A, then B to B. There is another here. Okay. So the apparatus required, we need the Kelvin double bridge and this unknown resistance and multimeter to measure the value of P1. So the unknown value resistance R is measured by PQ into P1. We know the value of P as 100 ohm and the value of Q to be selected as 1 kilo ohm, 10 kilo ohm, 100 kilo ohm. Okay, by varying this P1, we have to make the bridge as balanced. Balanced means we have to make the zero flow of current. Okay, now switch on the circuit. Okay, so I keeping that the value of P is 100, which is fixed value. Now the value of Q is selected as 10 kilo ohm. Now I am varying this. I am varying this one as P1. The value of P1 should be a 0 to 1 kilo ohm. So making this to be 0. Yeah, this thing. Now it is very close. Now it becomes a 0. After becoming 0, we can remove this two wires and we can switch off. Even we can switch off this. Then we can measure the value of P1. So we are getting this multimeter in ohm. Okay. Now the value of P, we know the value of P as 100 ohm and the value of Q to be selected as 10 kilo ohm, which is 10 to the 10 power 3 ohm. and the P1 is 0.968 kilo ohm, 0.968 kilo ohm, so that I can write as 10 power 3. By using this formula, R is equal to P by Q into P1, we can calculate the value of unknown resistance, which is R is equal to P is 100 and Q as 10 and P1 as 10 into 10 power 3 into 0.968 into 10 power 3. So this 10 power 3 will be getting cancelled. This will be cancelled. So the value would be a 9.68 ohm. So which is approximately it's a 10 ohm resistance.
Okay, here students, here is the Wheatstone Bridge. Today we are going to see Wheatstone Bridge. So the purpose of Wheatstone Bridge is to measure the value of unknown resistance. Here we are having the unknown resistance. So it is connected in the 4 arms in the unknown arm. Okay. So here there is a supply, power supply. So A to A connection to be given, then B to B, B is ground. So A to A connection, then B to B connection. Okay, so we can select the values randomly like 1K, 10K, 100K. So now I am choosing 10K. Okay. So in this dotted line we can shorten the connection. Similarly here also. And we can choose the value of R3 like 10 ohm, 100 ohm, 1 kilo ohm. Now I am giving 100 ohm. Okay. So one more dotted line is here. We must give connection here and to here. Okay. Now switch on the circuit. We can change the values by this. Now it becomes 0. So at this time we are switch on the circuit and we can measure the value of R2. The value of R2 should be a 0 to 10 kilo ohm. So for measuring the value of resistance, I am using this multimeter. So keeping it ohm. So the value is measured as 7.98 kilo ohm. The value is measured as 7.98 kilo ohm. By having the bridge balance equation Rx is equal to R1, R3 by R4, we can calculate the values and we can find the unknown value. Thank you.